All right, we're now in lesson 5.6 and we're solving radical equations. So to begin our lesson today, I thought we would do just a little bit of review on rational exponents, because a rational exponent, well, let's just get into some examples. Like when I raise the number 4 to the 1/2 power, that's the same thing as the radical form, the square root of 4, which of course is equal to 2. We can raise a number like 8 to the 1/3 power. Whenever an exponent is a fraction, it represents a radical, and vice versa. So this is another way of saying the cube root of 8, which is also 2. We can do something like 16 to the 3/4 power. And the way to turn this into radical form is this bottom number of the fraction becomes the index, or the root. And the top number of the fraction just stays with the base. And this looks a little complicated to do without a calculator, but if you break it up into two smaller pieces, like do the 4th root of 16, which is just 2, and then 2 to the 3rd power is equal to 8, which is our answer. So I just wanted to give you a little review. We've looked at this a little bit in the past, how a rational exponent, it's just another way of looking at a fraction. When an exponent is a fraction, then how does that translate into a radical form? So today's lesson is going to involve working with radicals in equations, or we could be dealing with rational exponents in equations. So I just wanted you to be comfortable, have a good understanding that really when we see a rational exponent, that's just another way of writing a radical, and vice versa. So let's just get right into some examples like your homework problems. I marked out these instructions these are given in your book. We do not require graphing calculator, so obviously you're not going to be able to do that. But I am going to have you to just, even if it's a mental check, check for what we call extraneous solutions, and we'll talk about that in just a minute. So for my first example here, when I'm solving this radical equation, it's an important first step to always isolate the radical first. All right, so to isolate the radical, obviously I'm going to need to add 4 to both sides. Okay, so remember in our previous discussion of radicals and rational exponents, the square root of 2x plus 4 could be thought of, it's the same as 2x plus 4 raised to the 1/2 power. So I'm showing you this over here in blue to kind of make sense of the next step that we're going to take. If you remember that exponent rule that says when one power is raised to another power, we multiply those powers together. So if I could raise 1/2 to its inverse, those have to be multiplied together, and it would produce 2x plus 4 to the first, or just 2x plus 4. So this is a good picture of the reason for my next step. Since this is a square root, or it's like raising this to the 1/2 power, the way I go about solving this is I raise it to the second. And if I raise the left side to the second power, I must also raise the right. So the effect of raising the left side to the second power, I get 2x plus 4. And then on the right side, I get 49. And now it's just a pretty simple Algebra 1-like equation. All right. And so I divide by 2. I just realized that I put 2x plus 4, and it should be plus 5. Okay, sorry about that. Okay, and so this should be 44, and x is going to be 22, I think. So an extraneous solution really means this. I get an answer that at least I think it's an answer, but when I plug it back in, it actually doesn't make the equation true. So this can be just a mental math check, but it needs to be a check. Sometimes you think you got the correct answer, but it turns out there isn't a real number solution. So let's plug 22 in for x and do this math. So 2 times 22 is 44. 44 plus 5 is 49. The square root of 49 is 7. 7 minus 4 is 3. In this case, there is no extraneous solution. The solution that we got is it works. It makes the equation true. And so that's my answer. All right, let's try this one. So isolate the radical first by subtracting 6. Raise both sides to the second power to remove the radical. And then go about your normal routine for solving for x. And so let's see if we have an extraneous solution. So when I go under the radical and I insert 1/4, 4 times a fourth is 1. 1 plus 8 is 9. The square root of 9 is 3. 6 plus 3 is 9. So it checks out. I do not have an extraneous solution. Okay, in cases like this where there are two radicals, it's important that the radicals are on opposite sides of the equation. And this one's already set up that way. So this is really pretty easy. I just raise both sides to the second power, and that takes both radicals away. And it gives me a pretty simple equation to solve. So if I add 13 and subtract x, I get x equals 9. All right, so let's see if that actually works. So here on the left side, I'm going to get the square root of 5. 9 minus 4, and I want to know if that's also going to happen on the right side. So 18 minus 13 is 5, square root of 5, so yes, this is a good answer. My solution is x equals 9. In cases like this, the radicals need to be separated. They need to be put on opposite sides before I start. So I'm going to add the square root of x to both sides. Now, I'm going to do like we've done in the past. I'm going to raise both sides of the equation to the second power. And the left side then will become x minus 5. When I do this right side, you do have to be careful here because this is a binomial, and we've talked about this before. When you square a binomial, it literally, in this case, it means -2 plus root x times -2 plus root x. So you're perfectly fine if you write it down twice and use FOIL, and you should end up with 3 terms as a result. Instead of doing FOIL on these binomials, I just like to do some mental math, and it works like this. I'm going to take the first term in the binomial and square it. -2 squared is 4. Then I'm going to multiply these two terms together. So -2 times the square root of x, and then double that, or multiply times 2, and you're going to get -4 times the square root of x. So that's an important step to get that middle term. You just multiply these together and then think times 2. And then finally, I'm going to square this last term, and if I square the square root of x, I get just x. All right, so now I'm going to go through and try to solve for x. If I subtract x from both sides, it cancels these. Probably see that. So let's try to isolate the radical. So I'm going to subtract 4. Now I'm going to undo multiplication with division. So divide by -4 on both sides. And now to undo the square root of x, I'm going to raise it to the second power, like we did in previous problems. And so I get 81/16 is my solution. And I won't take the time since my video is going to be kind of lengthy, but you can do this yourself. We did check this in class. It does work. You would just need to put 81/16 in for both of the x's, and it does check out. All right. This time we're looking at rational exponent equations, but again, that's just another way of writing a radical. 5p minus 7 to the 1/3 is the same thing as the cube root of 5p minus 7. So it looks a little different. So since this is a radical, our principle still holds true. We need to isolate the radical first. So my first move is to subtract 3 from both sides. And now I'm going to raise both sides to the 3rd power to make this become exponent 1. So since I raised the left side to the 3rd, I'm going to also do the right. 5p is equal to 15, so p is equal to 3. Let's check and see if it works. 5 times 3 is 15. 15 minus 7 is 8. This means the cube root of 8, which is 2. 2 plus 3 is 5. So we have a good answer, p equals 3. Okay, again, isolate the radical. The radical is this binomial raised to the 1/3 power. So we're going to add 6, then divide by 3, and just kind of jump to it there. So once I add 6 and divide by 3, I get this. Raise both sides to the 3rd power. And I'm going to get x plus 5 is equal to 8. And pretty simple, x is equal to 3. Let's check it out. 3 plus 5 is 8. The cube root of 8 is 2. 3 times 2 is 6. And 6 minus 6 is 0. Good answer. Okay, let's try this one. I'm going to add 4 to both sides to isolate the radical. And I'm going to raise both sides to the 3rd power. And that produces 4n minus 8 is equal to 64. Now I'm going to add 8 to both sides. And then divide by 4, and I get n is 18. And that is also a good answer. 4 times 18 is 72. 72 minus 8 is 64. Cube root of 64 is 4. 4 minus 4 is 0. Okay, one more, and then we'll move on to some inequalities. Once again, isolate the radical, and the radical here is, this is like the cube root of 14a. So that my first move is to multiply by 7 on both sides. And now I'm going to raise both sides to the 3rd power. So that gives me 14a is equal to 343. And dividing by 14 gives me a is 24.5. Okay, so let's check that out. We'll do 14 times 24.5. And then the cube root of that. And that's 7, and 7 times 1/7 is 1. So that's my answer for this example. Okay, so solving inequalities, a little different, and I've given you some steps here to follow. The first thing that we have to be sure of is that our solution for x does not create an imaginary number. Okay, so right off the bat, we're going to solve an inequality that ensures that x, in this case, is going to produce a number that is 0 or positive. So we're going to find out what that number is. So pretty simple. 2x is greater than or equal to -14. So my solution for x has to be greater than or equal to -7. All right, so that's my step 1. Step 2, I'm going to go ahead and solve the inequality much like we did when it was an equation. I'm going to isolate the radical. And then go about our routine. I'm going to raise both sides to the second power. And then solve for x, and you can probably see that x is going to be greater than or equal to 43. Subtract 14 divided by 2, 86 divided by 2 is 43. Okay, so these two numbers, my first step and my second step, I'm going to just put those on a number line. We did something like this when we were solving quadratic inequalities. And just think about these two numbers on a number line, and we're going to test around them. Now, I don't need to test over here to the left of -7 because I've got to have a number that's greater than or equal to -7, or else this is not going to be real. So I'm not going to bother testing here, but I am going to test in between. All right, so let's pick a number in between -7 and 43. Obvious choice, easy choice is 0. So if I plug in 0, I'm going to have the square root of 14, which I know has to be a little bit less than 4 because the square root of 16 is 4. So if you think about it, well, let's just say 3.8. All right, 3.8 minus 6 is not going to be greater than or equal to 4. So I know these numbers in this area do not work. So now let's verify that something over here, does it work or not? So let's try 44. So we get 88 plus 14. So 88 plus 14, and it's going to be 102. All right, so let's think about this. If it were the square root of 100, that would be 10. Well, 10 minus 6 is greater than, or it's equal to 4. So the number that's a little bit more than 10, obviously, is going to be greater than 4. So these numbers do work, and so my final answer is going to be all the numbers greater than or equal to 43. But this is going to be your process when you solve these inequalities. So let's do a couple more of these. So here again, our first step is to just take the part under the radical, it's called the radicand, and solve it. So I've shown you here. So if you subtract 4 and divide by 3, you're going to get y is greater than or equal to -4/3. In order for this to be a real number, y has to satisfy this inequality. Okay, now let's solve the inequality. And so we're going to subtract 6 to isolate the radical. And I'm going to raise both sides to the second power. That really doesn't change anything other than remove the radical. And when I'm solved for y, I get y is less than -4/3. So on my number line, I'm just going to have -4/3. And I'm just going to test on either side. Okay, well, actually, I don't have to test over here because this tells me that y has to be this, or else I'm not going to have a real number. So there's no need to test anything on this side. So I'm going to test the numbers that are greater, like 0. Okay, it's easy math. So 3 times 0 is 0, plus 4 is 4, the square root of 4 is 2. 6 plus 2 is not less than 6. Okay, so in this case, I can't choose these, and these don't work. So this is going to be one of those no real solutions. Okay, and let's try one more. All right, so much like we dealt with equations, we've got to put the radicals on either side of the inequality. But first, we've got to solve each of the radicands, and I've set that up for you. So in this case, d has got to be greater than or equal to -3. And for this one, d has to be greater than or equal to -7. Whatever we choose for d, it's got to ensure that both of these are going to be real. Well, if I let d be all the numbers greater than or equal to -7, that includes numbers like -6, and that would not work for this radical. -6 plus 3 is -3, and that's going to be an imaginary number. So even though this inequality satisfies this radical, it doesn't satisfy this one. This inequality, however, would satisfy both, because obviously it works for this one, and numbers greater than or equal to -3 plugged in here would also keep this from being imaginary. So even though I started off with two different options, really only one of them will work for both. All right, so now let's work on solving the inequality. So we're going to split up, make the radicals on either side. Okay, and I'm going to square both sides. So here's showing that step. So the left side's easy. The right side, however, I got to be careful because remember that three-step mental math process. If I square the first term, I end up with just d plus 7. Okay, now I'm going to multiply these together, and when I do that, I get -4 times the square root of d plus 7. But don't forget, you have to double that. So that makes -8 times the square root of d plus 7. And then you square the last term, and that gives you plus 16. Okay, well, just like in our previous example, when I try to get the d's on the same side, they're going to cancel. So I'm going to work on trying to get the radical by itself. So maybe we can combine like terms on the right side. 7 plus 16 is 23 minus 8 times the square root of d plus 7. Subtract 23, I get -20. -8 times the square root of d plus 7. Now I'm going to divide by -8. And so when I divide by -8 and reduce, it starts off as 20/8, but I can divide by 4, so it makes that 5 halves. And since I divided by a negative number, I have to switch this, so be careful there. Okay, and now I'm ready to square both sides, raise both sides to the second power, and I get 25/4 is greater than d plus 7. And now when I subtract 7, that's really 28/4. So 25/4 minus 28/4. I'm going to turn this around so that it says d is greater than, and that's going to be -3/4. All right, so maybe I can squeeze our little number line in down here. So I got -3/4, and I got -3. But according to this, to keep my numbers from being imaginary, this has to be true. I have to pick numbers. I got these switched. Sorry about that. Okay. So there's no reason to pick any numbers to the left of -3, okay? Because I've got to make sure that this holds true. So now I'm going to pick something in between, some number in between -3 and -3/4. Doesn't really matter what it is. Let's just try -1, okay? So if I let d be -1, I get the square root of 2. And here I get the square root of 6. And I want to know if that's greater than 4. If you have to go to your calculator, let's do the square root of 2 plus the square root of 6. And that's 3.863. Obviously not greater than 4. So these do not work. So let's try something greater than -3/4. 0 is a good choice. So I get the square root of 3 plus the square root of 7. And you can probably already figure out that that's going to be greater than 4. But let's go to our calculator. Check it out. Square root of 3 plus the square root of 7. That's 4.3778, obviously greater than 4. So these do work. And so my final answer is going to be this, all of the numbers greater than -3/4. So that's how the inequalities are a little bit different. They're a little bit more involved. And if you follow these 3 steps that I've provided for you, that should lead you to the answer pretty easily. A little bit of work involved in some of them, but it should lead you to the answer. Okay, so that's it. And if you have any questions, let me know.